Today, we're going to understand how QAM is generated in a communication system. We'll go step by step from a simple bit stream to symbol mapping on the IQ plane, and finally how those symbols are turned into real RF signals for transmission. Now let's start with the bit stream. We begin with a digital bit stream, which is a continuous sequence of zeros and ones. This is the most basic form of digital information inside any communication system. At this stage, the data has no structure for transmission yet. It's just raw binary information coming from sources like audio, video, or internet data. Before we can send it over a wireless channel, we need to process and organize it into a form that can efficiently carry information through a signal. So this bit stream is the starting point of QAM modulation, and everything we do next is about converting this simple sequence into a signal that can travel through the air. Now that we have our digital bit stream, the next step is to prepare it for modulation by grouping the bits into symbols. Instead of sending bits one by one, we collect them into blocks. In 16 QAM, each symbol contains 4 bitses because log 216 equals 4. So every 4-bit group represents one symbol that will be transmitted as a single signal. For higher order modulation like 64 and 256 QAM, we group 6 bitses and 8 bitses per symbol respectively. This allows more data to be sent in the same time, increasing the transmission speed. However, there is a trade-off. As we increase the number of bits per symbol, the signal points get closer together, making the system more sensitive to noise and errors. This step is important because it defines how efficiently and how reliably the information will be transmitted. Now we move to the most important step in QAM generation, mapping each symbol onto the IQ constellation. At this stage, every group of bits is converted into a specific point on a 2D grid called the IQ plane. This grid is known as the constellation diagram. For example, in 16 QAM, a 4-bit symbol is mapped like this. 4 to 0 becomes -3 -3. 301 becomes 3 -1. 0010 becomes -3, 1. And 0011 becomes 3, 3. Each of these points is defined by 2 values, I, which is the in-phase component, and Q, which is the quadrature component. So instead of thinking in bits anymore, we now represent data as positions in this IQ space. Now we move to the modulation step, where the I and Q values are turned into actual waveforms. We take one selected constellation point, for example the symbol 0001, which corresponds to I equals 3 and Q equals -1. This symbol is then split into 2 paths. The I value goes into the in-phase branch and multiplies a cosine carrier signal, so we get 3 times cosine. At the same time, the Q value goes into the quadrature branch and multiplies a sine carrier, which is shifted by 90 degrees. So we get -1 times sin. So instead of transmitting raw numbers, we are now using them to scale 2 orthogonal carrier waves, which is the core idea behind QAM modulation. After generating the 2 carrier components in the previous step, we now need to bring everything together into a single signal that can actually be transmitted over the air. Both the I path and Q path are still separate waveforms at this point. The next step is to combine them into one unified RF signal. Mathematically, this is done by simply adding them together. I cosine plus Q sine. This is a key moment in QAM modulation because it shows how 2 independent amplitude-weighted carriers are merged into a single transmitted waveform. Now that we've gone through the 5 key steps of how QAM is generated, one of the main advantages of QAM is its high spectral efficiency. By transmitting multiple bits per symbol, it can significantly increase data rate without requiring extra bandwidth. At the same time, QAM is highly flexible. We can choose different orders like 16, 64, or 256 QAM, depending on the trade-off between speed and robustness. This is why QAM is widely used in modern communication systems such as Wi-Fi, LTE, and 5G. Hope this video helped you understand how QAM is generated step by step. Thanks for watching, see you in the next video, and don't forget to like and subscribe.